Okay, so I'm going to go over one of the examples that I posted. Maybe talking through it will help clear up a few of the problems, a bit of confusion. The question says, find the slope of the tangent at x equals 1 to the curve f at x. So again, you want to recognize essentially we have some kind of a curve, whatever it happens to look like, and we're looking to find the slope of the tangent right at that specific point. That's a really bad example. How about right at that specific point? Now, if I've drawn that and it looks like a tangent and somebody else comes along and says, well, I think the tangent is more like this one at that same point, it's pretty hard sometimes to argue. So that's sort of the limitation of finding slope at a tangent. It's simply not something we can do. So what we're doing is using the idea of first principles, which is if we look at a bunch of secants that are getting closer and closer to the tangent, meaning the 2 points are getting closer and closer to being the actual same point, then we can look at the trend, and the trend will be that the slopes will approach a certain number. So the first slope that I calculated might be 2.3, and then I'll see a 2.2, and then I'll see a 2.1, and then I'll see a 2.05 and a 2.03, and recognize that, well, as that gap between the points gets smaller and smaller, it looks like my slope is getting closer and closer to the number 2. So here's our question, and sort of the first key here is to recognize that A is the value of x that I'm looking for. We tend to think of x in something like this, f at x, as representing all the possibilities, all the possible values of x. So just sort of in our formula, the definition of A is just the x I want. So it's the x that I want to find, at which I want to find the tangent. A plus h is the, so A plus h is the x of the second point. And again, what we're looking for is for the gap between these two things to get to so small that essentially we're talking about a tangent. So it's as this h value, so the number that's being added on to my x value gets close to 0, then if this is 1, this is 1.4, 1.3, 1.2, 1.1, I sort of get to the point where this is 1.000000, again, continuing down to the point where it's almost the exact same value. Which means that this ends up being the y2, so the y value of that second point. This is the y value of the first point, and of course they're subtracted exactly as slope always has been for us. Everything to the left here is just saying that mathematically what I'm doing is okay. You're not doing any work with the limit itself at this point. It's just sort of saying I can't deal with this with a value of 0 at h. If I plug a 0 in here, I get a division by 0. That's not okay. So this is saying, well, let's make it okay by saying we're not really putting a 0 in, but we're looking at what would happen if we theoretically could put a 0 in. So that's kind of, again, just a mathematically legal way of doing the question. And then basically the rest of it is just manipulating equations. My, f at 1, which is really what I'm looking for. This is an x value of 1. What happens when I put 1 in here? Well, if my original question is at 8 over 3 plus x, then I'm saying put the 1 in where the x was. And of course that's 8 over 4, which is 2. I'll get that in a moment. In the second case, I'm asking us to put in a plus h, which is really 1 plus h, knowing that the a value is 1. And so we put 1 plus h in where the x was. Now again, the rest of it is just mathematical manipulation. I could actually extend this line and say, really, we're not doing anything with the stuff on the left now. This is just a question where I'm asked to solve for h, or sorry, simplify this question as much as I can to get h down to a simpler term. And so that's, again, not necessarily calculus, just kind of manipulating a fraction here. And so 8 divided by, we said it was going to be a 2 over here. This simplifies a little bit to 4 plus h. I'll try not to go through that too slowly, because if there's a problem with anything in here specifically, ask maybe specifics, but the simplification should be something you can kind of work out. If it takes you a few more lines, no big deal. I'm not sure what that was. Hopefully I didn't just lose my audio. So simplifying now, on the top here in the numerator, I need a common denominator. The common denominator will be the 4 plus h. What I'm going to do is just divide the whole thing by h out here, so that it's separated from the rest of the question for now. And so this is already over 4 plus h, so I need a 4 plus h here and here, of course. Remembering that dividing by h is the same as multiplying by 1 over h. This was just kind of a note to say what I did on the next line, which was just kind of put the h in the denominator now. The top simplifies a little bit from here. Subtract. And remembering that my whole purpose in doing this has been my problem from the start. We really want to see what happens when h gets to 0. Or at least h gets really, really close to 0. Now that we've got a simplified fraction here, I can divide out by 2 h's, and what I'll be left with is negative 2 over 4 plus h. Now if I actually do the substitution for the 0, I don't have a division by 0 anymore, and so I end up with negative 1/2. So again, last time, none of this actually do I have to work with in any way. It's just saying, let's assume it's okay to go ahead and do this question. Even though we know that technically we can't plug the 0 in, this is going to say, well, really what we're looking at is what happens if we could plug it in, and that allows us to then go ahead and do it and solve it. So while we can't actually draw this picture and put in 2 points to find our slope, we're saying that if we put in values that we could put in that were really close together, we would find that the closer we get together, the closer our slope gets to this negative 1/2 number.